Good evening, and from my understanding, I'm the one keeping you from drinks and cocktails right now. So, my name's Dean Zodi. I am founder and CEO of Ghostwave. As Charlie mentioned, Ghostwave is out of Columbus, Ohio, and we have 4 radar patents exclusively licensed to us from Ohio State University. There's a problem with radars. They're frequently used on your car for safety, for blind spot detection, lane change assist. They're also used on drones for collision avoidance. And the problem is there's an opportunity for hacking and jamming and interference of these radars. They operate off of a finite number of signals, and with the proliferation of radars around you, we're increasing the chances that your radars are going to talk to each other, interfere with each other, or somebody with malicious intent can jam your radar. Ghostwave has a solution to this. With the patents licensed to us, instead of using a finite number of signal, we have millions of random signals that we're sending out in different waveforms for our radars. This makes them immune from hacking and jamming. It improves the quality of your detect and avoid system on your UAVs, unmanned aerial vehicles, or drones, and for your safety features in your car. Why are our radars better? Well, from the chart here, again, we mentioned the immune from interference. We work and play well with other radars in the vicinity. We have wideband signal generation, which means we can generate millions of different signals. And again, we're immune from jamming. This is proven technology. Several years ago, the Army commissioned a project to Ohio State University. And with that project, they wanted to put radars on the bottom of helicopters for ballistic identification. Excuse me, somebody's shooting at you, it's this caliber of a bullet. But the Army also said these radars need to be stealthy. We don't want a threat on the ground to be able to lock into the radar and shoot down the helicopter. Well, the technology that makes the radars immune from detection or makes them stealthy also makes them immune from interference. Detect and avoid systems are going to be crucial when you look to the future and you see the Amazon drone delivering packages to your house. You want to make sure that the whole drone doesn't crash into a building, wreck into a tree, or other drones flying around in the air. Right now, the FAA says you cannot fly beyond visible line of sight. However, that is expected to change soon. And in the near future, the FAA is expected to say, okay, you can fly your drones beyond visible line of sight, but if you're going to do that, you're going to have a detect and avoid system on your drone. Well, there's a problem with detect and avoid systems. Typically, if you've seen photos of drones, you see a camera hanging down on a gimbal underneath the drone. Well, if it's dark, if it's smoky, if it's foggy, if it's cloudy, the cameras don't work very well. So, Ghostwave has a solution. We're going to take the existing camera, we're going to fuse that signal together with a Ghostwave radar, and we're going to feed that information to the autopilot of the drone. Now, if there's something that is detected that's a threat, the autopilot will take evasive maneuvers either to stop or move out of the way, then continue the mission when the threat is cleared. Ghostwave, if you look at our state-of-the-art solution, you could have multiple sensors on your drone. However, if you take the Ghostwave radar with a camera, combine those signals together, you have the best solution for detect and avoid. Ghostwave just recently got a contract from OFRN, or Ohio Federal Research Network. The requirements of the OFRN is to have industry partners, university partners, and it's an 18-month project approved by OFRN. Well, we're working with Lockheed Martin for their drones and doing a detect and avoid system for them. It's a $1.3 million contract over the next 18 months. We're also including Ohio State Center for Design and Manufacturing Excellence, Ohio State Electric Science Lab, and OU Avionics, which has a very strong avionics department. Is this a big market? Well, according to Research and Market Report this year, in April, the detect and avoid system for drones is going to be $3.6 billion by 2023. Ghostwave, where we're going or where we've been, We originally got a grant from TVSF, which is Ohio Development, for Technology Validation Startup Fund. That, with the help of an incubator in Columbus called Rev1, we got the TVSF grant. We went from the big radars that we mentioned earlier for the helicopters and shrunk that down to 24 gigahertz automotive-sized radar. After that, we went forward and applied with our university partners and Lockheed Martin and received a contract for OFRN. By the way, and since then, Ghostwave has kind of done a pivot. The interns at Flashstarts were awesome. They were just amazing, I know. They were amazing in helping us kind of pivot, get the right marketing information together, and any of the good slides you see here are thanks to the interns. The bad ones are all mine. Our team, Dr. Walton is a retired professor, listed on the patents license to us. Dr. Villarol spent 17 years doing antenna work in the automotive industry. Another PhD on our advisory board, specialized in commercialization. The whole Ghostwave team is way too thick, except me with PhDs. And then finally, we talked about really cool drones as the title of this presentation. There's a whole nother application that, if you want to stop back at my table and talk about, it's about using radars, the flap speed of honeybee wings, and monitoring the health of your honeybee hive to avoid mites and other colony collapse disorders. So again, thank you very much.